And we will have Tim Lenton from, that you know already, Antonio del Rio,
Tonio, are you
who is
there
going
online?
to be online.
Tonio.
Yes, I am here.
Great, okay.
Hola, Toño, buenos días. Patricia Balnavera, del Instituto de Investigaciones en Ecosistemas y Sustentabilidad de la UNAM. Francisco Estrada Porrúa, del Programa de Investigación en Cambio Climático de la UNAM. Y la mesa estará moderada por Julia Tagueña, del Instituto de Energías Renovables del C3. Adelante, Julia.
Well, thank you so much. Well, let me tell you that this is going to be a positive tipping point. Right? Okay, yes, of course. So we have agreed that I will just put forward some questions that you will answer in turn, and you have more or less 3 minutes to answer. So let's go straight to the first question, which says the following: why are climate change and environmental degradation complex problems? And let us start with Patricia.
Thank you, Julia. Thank you, Chris, for the invitation. Thank you, everybody, for being here. So, climate change and environmental degradation, I want to explain they are complex because, one, there are multiple interacting dimensions. 2, there are power relations embedded that regulate many of these interactions. And 3, there are emotional and experiential dimensions that have not been taken into account. So the first one are these multiple dimensions that are of a very different nature and that operate at very different temporal and spatial scales and are all the time interacting. So for instance, of course, in these climate models or in biodiversity models, we speak about water, energy, nutrients, biotic interactions, exchange of organic matter. But societies also exchange knowledge. They exchange cultural perspectives, values of the society. They exchange economic exchanges, so the value of the different products and the monetary exchanges. Political dimensions and historical dimensions. And all these are regulated and somehow embedded into power relations. There are very deep structural power relations that determine who makes the decisions and who participates and what are the rules of the game. And these have been defined by historical colonial interactions and currently by neocolonial interactions. And today, one dimension of power that is very important is discursive, how you frame the climate or the environment or the development vision has a huge power. And we see today the power of media, the power of social media in imposing particular narratives. And here, a third issue is that these narratives speaks and this power and exchanges speak in different ways to different people. So someone in the Sierra Tarahumara in Mexico experiences in a very different way than someone in New York or someone in the Pacific Islands. And every species too in the world, a fish experiences water in different ways that we experience water when we drink it. And all these experiences are really not being taken into account. They are being washed away by this dominant narrative of fear, of danger, of lack of hope that is really paralyzing the possibility to address it. Thank you.
Thanks a lot, Patricia. Let's go now to UK. Tonio, could you answer the question, please?
Yes, thank you, Julia. Well, Patricia told the most important things, but I think that really climate change and environmental degradation is not just complicated, like building a jet machines. Climate change is complex because exhibit emergent properties that arise from countless interacting components. Then the multiple interaction subsystems are the more important subjects. The way where the subsystems interact are really more important than the subsystems in itself, in my opinion. And environmental, biological, human and economical systems are really interesting. And these are an example of this complex behavior. Nonlinear dynamic and the thresholds are also a manifest of the complexity in the climate change. And as Tim mentioned, the tipping points are very, very crucial to really say that there is a change of the behavior on the complete system. The emergent behavior, I think that the world system exhibits properties that none one of its parts possess individually. And then we cannot predict global climate patterns just by understanding atmospherical, physical, or the biological of the ocean, of the solar forces, for example. Also, the economic recession emerged from individual decisions, but cannot be predicted for any single actor. As we observe, the tariff in this moment, there is not prediction about how the economy can behave. Also important in this complexity is the uncertainty and the irreducibility. We cannot reduce the problem and only one system or only one interaction. We have incomplete data, and we need to create more data. And this is one important difference with the global north and global south, that the global north has much data, maybe not completely, but much more data than in the south we have. Then I think that the complexity is beyond not only of the physical system, but also from the socio-technical complexity, and of course governments. But Patty also emphasized this point. Thank you, Julia.
Thanks a lot, Toño. Let's come back to Mexico now, Francisco. Oh, él tiene una. Mm-hmm.
Does it? Okay, thank you. Well, there's not much to add to the definition of complexity, but I'm going to try to talk more about examples. No? Well, first, climate change was bound to arise or to emerge from the interactions between industrial society and the climate system. No? And we have now clear examples, for example, that are really, to me at least, are really surprising. We did a paper a few years ago where we could find in global temperature the influence of, for example, the Second World War, the First World War, and the great crash of the economy. So that you can see in global temperatures. If that doesn't scare you, I don't know what will. And also you could see, for example, in global temperatures, the influence of China. For example, at the end of the 1990s, they decided to change how to produce rice. No? So they used the water in a more efficient way, and they changed the way of producing rice. And then this had an impact on microbes that produce methane. And you can see this in global temperatures. So that's the level of interaction and complexity we're dealing with. No? And I was very impressed with Tim's talk, very inspiring, but I tend to be a little bit more negative. Sorry about that, but it happens. So I'm worried about the negative tipping points, societal and political negative tipping points. We're actually in the Climate Change Research Program here at UNAM studying geoengineering. These things of injecting aerosols in the stratosphere, which by all means is completely crazy. We shouldn't do it, but we really need to study this because we don't need the world to be all together on that. Some of the great world countries can do it by themselves, no? And there are a lot of risks about that. I'm just wanting to talk about one of them, which is a negative tipping point. Now we're suffering the impacts of climate change, and then society becomes less risk averse to some types of solutions. Now, and then we can trigger socio-political tipping points, for example, adopting geoengineering solutions that will eventually trigger geophysical tipping points. No? We have these problems with geoengineering that is called the termination shock. So you kind of balance, or you remove some of the warming that you are perceiving now, because you're putting a lot of aerosols in the stratosphere. But what happens if you need to stop that? For example, if you have a world war or something that you need to stop this. So, for example, if you avoided 2 degrees of warming, you would get it back in about 5 to 8 years. So that for sure would trigger very important geophysical tipping points. So I think that's important to add to the discussion. Thank you.
Well, talking about strange possibilities, have you heard about putting a big umbrella between us and the sun, so we won't have so much radiation? Okay, so let's finish this first round, Tim, with you talking about how these problems are complex systems.
Yes, I loved the other contributions. I guess I conveyed in the talk my application of complex systems thinking here. What I'm also doing though as a science communicator is responding to the fact that as a teacher as well of complex systems, there's a lot of work to do with different audiences and students, right? My students walk into my class and they haven't heard about systems thinking, even though they're very bright, or I interact with policymakers who have never heard of systems thinking. So in the way I tell the narrative I did, I'm using tipping points as a accessible way into the complexity that faces us, whether it's the complexity in the Earth system and the climate, or the complexity of thinking through how we transform economies and societies. I observe that my class and many audiences get what I call paralysis by complexity. Like sometimes they're just like, oh my God, these invisible gases are causing these things that I'm not sure what they are, and da da da. Basically, I find it quite helpful for various audiences to give them a concept in tipping points that they can intuitively grasp, and use that as an entry point to engage in the complexity, both the risks and you could say the opportunities, in a way that's whilst it's scary on the risk side, it can be empowering on the societal transformation side, so that we're not just like paralyzed by complexity or the enormity of the problem, but we've got some way into engaging with complexity, even if we don't have the luxury of all the panelists, and we're all trained in complexity thinking for decades. So for us, it's like normal. So yeah, this is a slightly sideways answer, but I'm really interested to hear about what's going on at the center, and I'm sure we all wrestle the same challenges of communicating complexity as well as trying to understand it. But I believe there is a way to do that helps many audiences. Yeah.
I think this is a great point that has been touched during the meeting, the importance of language, the way you speak things, the way you explain. And well, yes, we have to find the communication way to convince society of all these issues. So let's go to the second question. What are the implications of their complexity for their analysis and the development of possible solutions? So we all agree there are complex systems. How complexity can help? So let's go the other way around. So let's start with Tim. How do you think that complexity can help to solve these problems?
Well, in as much as part of complexity is this knowledge of potential tipping dynamics where change becomes self-propelling, it can certainly help if it's change in a good direction. But as I think Francisco and maybe all of the others were hinting, things can tip in bad directions as well. So it's not a guaranteed help unless you have, how can we put it, some kind of additional moral compass or collective understanding or pursuit of the public good. But still, I think we do have that. It may be faltering in places, but every survey shows that like 80% of people support an accelerated action on climate change. So yes, I believe the complexity dynamics of tipping points are really interesting, but they show us these interesting lessons that multiple actors can come into alignment and that can accelerate change. So to simplify, if bottom-up social activists who are driving for action on climate start to align with top-down governance, it'll always be they can reinforce each other. It'll almost always start with social activists, but governance sometimes comes round, like it did in Norway. And once those two groups are working together, they reinforce each other, because basically, at least in democracies such as they are, the politicians don't have the courage to act without a sense that the public are behind them. So yes, I think the beautiful complexity of those actor interactions can help if we can get it aligned. And that extends also to the role of, for example, business and entrepreneurship. Of course, they can get in their own feedback loops with policy, where we'll see new power structures and political economy lobbying for the clean technologies and reinforcing those. So there's too much to talk about there. So I'll stop. But I really found myself writing the book on positive tipping points, just trying to unpack that complexity towards an agenda of accelerating action. And I realized, oh wow, there's a whole lot of ways in which accelerating change can happen. And luckily, the beauty of the complexity is there's no one perfect way of coming into alignment. Luckily, it can be a bit clumsy, but you can get to an accelerating good outcome lots of different ways. And that's quite a comforting message, I think, in these troubled times.
Good. Okay, Francisco, your turn.
Negative again, but yes. But for example, there is another way of defining this type of problems, which is wicked or super wicked problems, no? Which are basically problems that are social at heart, no? That there is a socioeconomic problem, no? Climate change. I'm going to say the word, but then I'm going to say that it is wrong to use that word. If we solve it, it's going to be true societal change. But the problem is that wicked problems, you cannot solve them. You can make them worse or you can make it better. But there is no way to solve a wicked problem because of the complexity of the systems involved. So this I think we need to keep in mind, no? And also, well, if we think a little bit about how we deal with other wicked problems, as, for example, poverty or education, a lack of education, we haven't been very successful at doing that, at least in countries as ours. And And that has to do with, well, many things, but this myopic view that politicians have, that cannot see beyond 3 or 6 years, that's a big problem. And people like, I don't know, those who work at the climate change research program, that we have a lot of contact with decision makers. Of course, you at C3, you also have that. You can see this big wall of I cannot see beyond my political time in power. No? So given these two types of problems is that we cannot really solve them, and that there are social problems, not natural problems at heart. And the lack of ways of dealing with the long term, I think we are in a big problem. So I will leave it there, but I'll come back.
Yeah, I think it's clear we have problems. There's no doubt about that. Tonio, your turn, but let me ask you, Tonio, if you could perhaps mention something about sustainability, because this roundtable is called Climate Change and Sustainability. And as you just mentioned, problems are not solved, but you can walk in the right direction or not. So, Tonio, please.
Thank you, Julia. Thank you for reminding me this. I think that one of the most important things that a complex system offered to the people to say that we can look for a pathway to sustainability is that there are so many indicators to monitorize the system that we can select specific indicators and say that we are going in good direction, but also pay attention to others that they are in wrong direction. This kind of selection of indicators allows us to really communicate good knowledge in sense that the big put the alarms in the people, but at the same time saying that we are doing good things. For example, if we analyze the use of energy per capita, we can see that in the last 20 years, most of the countries are diminished the use of energy per capita. And really in more than 20%, all the countries have diminished the energy, except China. China is growing the use of energy per capita. But if we analyze not the use of energy per person, if we analyze the energy needed to produce one GPD dollar, for example, we can see that the efficiency of the world is really diminishing. I agree that it's not in the speed or with the acceleration that we want, but we can send the correct message. We are taking actions in the correct directions. We are diminishing the intensity of energy in all the economies. And it's really dramatic, the change in China. It's very important to select not the bad bad indicators, but also that the intensity in use of energy in the economy of China is really almost diminished to one half in 20 years. For example, in comparison, Mexico is almost flat. Okay, the energy intensity in Mexico in 20 years is almost flat. That means that we are not using our information to introduce actions. And I think that the complexity help us to select indicators. I use I use only energy indicators, but we can look for many others. And in the way that we communicate to the people, we can say, okay, please pay attention. We use more energy each time. Okay, we need to reduce the use of energy. We need to reduce the emission of CO2, but we are doing good actions. And we can follow these actions and try to promote these turning points that Tim mentioned and also Patricia. And let me say that thing. In sustainability, we need to find the trajectories and we need to modify the trajectories by defining good indicators, and we need to promote to the people the use of indicators to path our sustainability trajectory.
So complexity can help us to follow the indicators of the Sustainable Development Goals, right? Through complexity methods and analysis. So now, Patricia, your turn.
Thank you. So if I come back to my premises where there are these multiple dimensions and multiple experiences and power relations among them, then addressing complexity approaches to solution means really working in these coalitions among these actors. And I want to speak to two examples, one more of a top-down kind of nature and another one of a bottom-up nature. So I have been involved for many years now with IBES, which is the Intergovernmental Platform on Biodiversity and Ecosystem Services, which is the analogous of IPCC, but for biodiversity. And for example, within the IBES, I had the honor to co-chair an assessment on the role of how we value nature on sustainability. We had around 100 authors from 55 countries. For 4 years, we assessed 55,000 sources, including scientific sources, but also governmental reports and even art and cultural pieces. Our main message was that the crisis we are living is based on the fact that the very diverse ways in which people value nature in different contexts for thousands of years are now completely ignored and overruled by a very narrow dominance of economic values within short-term material and individual benefits. And addressing this complexity has already yielded consequences in terms of building the Kunming-Montreal Biodiversity Net framework that is being negotiated by around 300 countries for their implementation by widening the kinds of values of nature that are in the table. Another bottom-up example is to work on the other side, on the very vulnerable actors of society, the people who live in rural and peri-urban conditions that grow food. We've been collaborating with these communities through a combination of artistic and scientific tools to co-construct more sustainable and just food systems. And here the premises are about understanding the conundrums that these people face directly by them and weaving their knowledge with scientific knowledge and really deconstructing the power relations between those who know and those who do not know, but rather weaving the different experiences and the different tools by doing very simple things, just as cooking and eating together, planting together and garden and regenerating the soil, or by gathering together histories about the past and ideas about the future to really create these coalitions. Thank you.
Well, thank you so much. We are all in the final round. This is going to be the final question for closing the table. And it says, what can we do about it? And it's important that you give us some hope, because I have grandchildren. I am worried about it. And not only my grandchildren, the grandchildren of all of you. We really have to make something. So let's start with you, Patricia. Let's do it again around.
Thank you very much. Yes, I absolutely want to start that what we can do about it is to think about hope and to think about these positive tipping points and to really nurture the agency that each individual and each collaborative has to really scale up the implications. And for doing this, my main argument is that we need a transformative science, a transformative approach to the way we generate knowledge that really addresses what IPBES has called the need for transforming practices, the way we do things, structures, the way decisions are structured, the governance, and views, the way we see the world. And so transdiscipline is a way to do this transformative science. Transdiscipline is used to think about transcending the disciplines and going beyond each discipline, beyond science, but also transcending the founding paradigms of how we see the world and what is our view of a good future of a development pathways. And so in order to seed this really very deep transformative change, I would argue that we need to change the way we, a bit what Tim was saying, the way we train the next generation. Really, capacity building is not just about being able to understand the complexity, but also to work with these different sectors and to really be embedded into the way they experience the issues and how to tackle them. And this has to do with also making sure we make collaborations with all different kinds of actors in business, in local communities, bottom up, top down. And we have not been trained to do this. And also the financial resources we have for doing this need to really be able to allow for these collaborations, and our institutional structures within, for instance, our university really need to reflect on what as a scientist has to do. Stay in our offices all day long and publish papers, which we certainly do somehow as we are here, or do we really need to be there on the battleground where the Kunming-Montreal framework is being negotiated, or in the battleground where climate change is hitting very hard the rural communities that are producing the food that nurture us? So I would say basically we can really contribute to this positive tipping point by radically changing the way we do science.
Thank you. Thank you. Tonio, your turn.
Thank you, Julia.
No.
I agree.
I was following the same.
Yes, I agree completely. Yes?
Yes, Tonio. Yes, we have a bit of confusion, but it's your turn. It's Mexico, UK, Mexico. Okay.
Okay, thank you, Julia. Well, I agree from the scientist point of view completely with Patricia, and I will not talk about that. But I think that also we need to think in different ways. In this moment, I think that there are very, very few people living in the world that were born before the use of fossil fuels. Most of us, we grow in a fossil fuel world, really. Then we need to think in different way. The solution, the system, we need to create cities to mobilize people and products and not vehicles, for example. We need to think in different ways. When I I study the electromobility, and when I say we need to buy some electric vehicles, the people say, okay, but the electric vehicles are very expensive and they take a lot of time charging the battery. But if there are very big machines to charge in very fast the electric batteries, then the battery is degraded in so fast way, then the battery cannot be recycled. Well, we need to think in different way. Why a vehicle need to be charging in a specific space? Why not we remove the battery and put a new battery, a non-new battery, but a battery charger, take away the empty battery and charge the battery in one place. This is swapping batteries. So then exchange batteries. This is a model different. And most of the people say that the electric vehicles are really expensive. But if we subtract the price of the battery, the price of the electric vehicle will diminish in around 40%. And then what is the difference with an electric vehicle and the equivalent gasoline vehicle? It's almost the same price. Really, it's very important to think in a different way. I am putting only the example of the electrical vehicle. I am not saying this is the way. I am saying this is a way to think in different form. The price of the electric vehicle with a battery is the same that the battery without gasoline. The only thing that we need to pay is the energy to move. And if the battery is removed and charged in a good way, the possibility of recycle the battery is higher than if we charge the battery in a fast way. Then we need to think in different way. We need to think that we can mobilize the people from the place to work, from the place to live in not motorized vehicles or walking, or not in an automobile, in a public transport. We need to modify the cities. I think that one of the world's idea was the creation of suburbs in some big cities. We can create small neighborhoods where the people can have fun, have education, and have work in a neighborhood around to 20 minutes, for example. We need to think in a different way, not because we are living in a world dominated by the fossil fuels. We need to think that this is the solution, and this is the way that we can create a sustainable world. Thank you, Julia.
Thank you, Toño. Back to Mexico. Now you turn, Francisco. Now, Francisco has been very realistic, so give us some hope. But let me tell you something. There is a hope because the National University has a program that you lead on climate change.
Of course, I agree, but hope doesn't come for free. No, you have to build the conditions for hope, and we're kind of late on that. So no, but yes, for example, we published a paper last year about the adaptive capacities around the world, and one thing that gives me hope is, for example, that one of the most important thing is what people think about climate change in countries. This defines the capacity of that country. For example, Mexico is the most worried country of the world about climate change. Mexico's population is willing to do things about climate change. They are conscious that it is already affecting them and it's going to affect them more in the future, so they are willing to do things. The sad part is that the second most important thing is institutional strength. No, lack of corruption, rule of law, science. And then in that part, we're in the middle of the table, which is tragic because all this concern of the people doesn't really pass through the institutional part and become laws and things that we can act upon. No, so that's something that concerns me, no? And also, one of the things that really concerns me as as a coordinator of the Climate Change Research Program is that a paper came out 2 years ago about the productivity of papers dealing with climate change in the world. 52 countries, Africa, Asia, North America. We are in position 47 of 52. We have 1,800 papers, published papers from in the last 30 years. So if you think that maybe, for example, CONACYT or CECITI now asks about 2 papers per researcher per year, in 30 years, all we have published about climate change is equal to the effort of 30 persons working, 30 researchers working on climate change. So that doesn't give me a lot of hope. This is where I come from. No, this is, we need to build the conditions to have hope. No, thank you.
Yes, I agree. There is no free lunch, right? Okay, Tim, we are going to close with you. We will finish the roundtable and open to questions of everybody here in the audience. Just let me tell you that Mexican women will vote from a long time ago, and there was a wonderful movement, feminist movement, that got the vote in Mexico. Okay, now your turn.
Yeah,
and well, yes, we can. Yes, we can. You are right.
Yeah, yes, we can. Yeah, what can we do about it? I said a few practical things at the end of the talk, but I probably want to pick up on what Patricia says, because I completely agree. I think the deepest tipping point is really a shift in worldview. I think as the scientists who hopefully understand this different view of the world, it's beholden on us to try to communicate what we've learned and hope that that shift in worldview can itself spread. I mean, I would call it Gaia because I'm a scholar of the Gaia hypothesis, but I think whatever you want to call it, this view of us as a part of and within this extraordinary life support system that we depend on, that doesn't depend on us, and is kind of largely run for billions of years by microbes, and all its beautiful complexity and our kind of interdependence upon that has somehow got to be got across culturally, because from that will then flow a completely different notion of nature and a completely different valuation, as Patricia put it. Because yeah, without that kind of deep tipping point in worldviews, I think we're still in the deepest trouble, basically. So I think for me, that's where I'm going to keep pushing, as well as trying to give pragmatic suggestions about how we positively tip behaviors and technologies. I'm going to continue to try to also communicate this. For me, it's like a scientific revolution that's happened very quietly, where we now see ourselves as part of this integral life-sustaining system that looks a lot like a lot of indigenous worldviews, but adds the beauty of some like quantitative observational evidence about it that nobody had seen before, and makes it even more remarkable to appreciate, you know, you just wouldn't have an atmosphere to breathe or a relatively cool climate without all the actions of past and present life, a lot of which you barely even think about. So yeah, that's that from my personal point of view. I think I'm passionate about communicating that shift in worldview, because it's shifts in worldviews that ultimately underpin truly transformative change. And we kind of need to get out of the 400 years since the scientific revolution into a different worldview and a different way of functioning as a society and relating to everything else, living or otherwise, that we need to flourish. So yeah, that's what we need. That's the big picture of what we need to do. It's a big ask, but I think we have to, as our little subset of society, champion that fundamental shift in how we see our place on Earth and in Earth and in the world, and take forward all of the political and other consequences of that, and advocate for that, really. Yeah.
Well, thank you to all of you. It was a wonderful panel session. Thanks a lot. And I think we have time for a couple of questions, right? Okay.
I'm amazed that there isn't 75 hands going up here to questions. I have a few, but one thing is that, the thing about complexity, meaning it's an incredibly multi-causal system, right? So multi-causal means multi-data source, let's call it, right? So in other words, more often than not, every discipline is looking at all the consequences, all the potential causes from a particular disciplinary point of view, which means a particular data set, that, et cetera, et cetera. So, the question there is what efforts have been made, first of all, for the integration of data sets that across disciplinary, let's call it, and then also, also the big question thinking about the next roundtable, it's artificial intelligence, machine learning, et cetera, that more often than not, the tool sets that we have, let's do a couple of regressions or something like that, are not up to the task for, understanding the, let's call them the complex causal chains, which are behind climate change in the first place, right? So that would be, my question.
Okay, who wants to go on it? Yep, Patricia.
Yes, thank you, Christy. I think this is a fantastic question. And I want to go to the example of the IPBES values assessment. So the way we dealt with these 55,000 sources is that we had 50 different search and analysis protocols. And so some of these protocols were about touching upon the very classical literature in the economics, philosophy, and so on, and really going through a very deep, deliberative analysis of how value of nature was conceived. And this led to a very interesting typology of values that is now widely used for decision making. So it's a combination of how you search and how you analysis. No? So that would be one. On the other hand, we did have a couple of searches that were aided by artificial intelligence, because when we search in literature and you use some keywords, the amount of papers that directly are retrieved is very reduced, because the searchers tend to narrow these. So we use artificial intelligence to first have a much wider set of papers, and also to strategically analyze the abstracts, to then have more analytical tools where we could have either qualitative or quantitative analysis of this information. So basically, to respond, I think because of this multi-causality and this very incommensurable nature of these different causes and dimensions, we need to really have very different strategies that are combined.
You want to add something? Please go ahead.
Now I'm going to be positive.
Wonderful, wonderful.
I want to invite you all. We're working on the second national assessment on climate change. So please, if you can't contribute, I know you have a lot of things to contribute to this assessment. And also, we have this data pink at pink to, if you can't contribute with data to this web portal, please go ahead. And what else? Also, well, for dealing with this complexity, we're trying to develop integrated assessment models. For example, we already have one for agriculture, we have one for biodiversity, we have one for only climate, and we have one for the economy. How much does it cost to Mexico, for example, or the whole world? I'm not going to be positive here, but during this sexennial, these 6 years we have, the losses we're going to experience here in Mexico are equivalent to losing today 24% of GDP, of this year's GDP. Just to have an idea, COVID costs about 8% of GDP. So please, I mean, we're here at the Center for Complexity. Please join us in these efforts.
Tim, I think you wanted to mention something.
Well, just to say that, yeah, in my group, we, for example, training deep learning to do early warning of tipping points before they arrive, and even try to tell us how close the tipping point is. So you want that both for the bad tipping points and the good tipping points, and it's certainly able to achieve good skill. And my group also works to a degree on improving causal inference in complex systems. And I think there's a lot of scope from what we've done so far to use a combination of theoretical mathematical advances and deep learning where appropriate to do better at inferring causality in complex systems. So plenty of good research to do there. But I'm also a bit sanguine about the enthusiasm for AI, because as far as I can see, some monopolizing massive tech companies are using it to maintain their monopolies and to continue to sell us even more stuff that we don't really want, and drive the problem. So I have a bit of a mixed feeling in the bigger picture there. Thanks.
We have a last question here, Rafael.
Well, yeah, we're living in tragical times and facing.
Well, put it closer. Voice. Okay.
Is it?
Okay. Okay. Right.
Shall I speak louder?
Perfect. Yes.
Yes. I said that we're living in tragic times, and facing complex systems like climate change and sustainability. I'm a physicist, and I turn to look at systems in a very simple way. First, I start by looking at the forces that are acting there. And exactly, climate change and sustainability are contradicting each other in many ways. And just because of the main forces that act on the system are economics, resources, and political decisions, right? In the normal world that I used to live when I was born, both things need resources, and the economic enterprises got their resources from their profits, which is a very unphysical notion. Yeah, but they work that way, and the more profit, the better. And the political get their resources from us, from taxes. Yeah, so in a normal world, they are opposite. And the politician's mission is to look for the good of the people, while the economic people look for their profits and things. What we're looking at today is that politicians have become to the other side. They serve the interests of people who are interested in profit. So I think this is the main problem that we face in order to solve what we are talking about here, climate change and sustainability. So I would like you to comment on that.
Okay, who wants to say something about this? Tim, go ahead.
Yeah, I couldn't agree more. I think we're in unusual times. There are times that it's been like this before, like at the end of the 19th century, turn of the 20th century, where the Industrial Revolution had led to the concentration of power and monopolization of the economy in the hands of the few, and there was clearly a lot of elite capture, as it's called, a lot of politicians and politics was essentially bought by often corrupt monopolists in a very unfree market economy. But of course, what happened in the early 20th century was that then provoked a whole lot of responses. In the US, it's the start of the progressive era, essentially, where the monopolies do get broken and there is a New Deal and there is transformative social change. We could cite universal suffrage and many other positive examples of reactions to break this kind of corruption. I think we're in broadly similar situation of monopolization, corruption, and elite capture at the moment. And we have to have a similar level of social movements in response. We don't necessarily see that as clearly as I would hope we could or would yet. But I think the potential, I hope, is there under the surface.
Toño has his hand up. Go ahead, Toño, and we'll finish with that.
Thank you, Julia. I think I see the nature of sustainability that to build sustainability, we need to focus on efficiency. And right now, the economical sector, the population, and also the nature is working to maximize the fluxes, to maximize the power. Imagine like a machine can work in the maximum power regime or in an efficient regime. And right now, the people try to extract most of the money in the faster way, but also the nature works like this. If we put a bunch of bacteria in a good environment, the bacteria will try to finish immediately the environment. And if we want to construct sustainability, instead to try to maximize the fluxes, move to a more efficient way. I am not saying that this need to be really efficient, but we need more efficient in all the senses, economical, resources, and economic, looking for efficiency to obtain satisfaction for the people. We need to only take into account that the energy is only thing that entered to this planet, and also is the only thing that leave the planet, receive in the part that is illuminated energy and throw away in the part that is at night. All the other systems in the planet are constant, let's say like this, and then we need to move in this machine and try that this machine will be efficient for all the species that we are sharing this planet. And this is the way that I think we can construct sustainability.
Well, I think we have to finish now, but let's big applause to our participants.
Muchas gracias, Julia, y muchas gracias a todo el panel. Muchas felicidades, gracias. Thank you, team. Thank you, Toño. Entonces, 3 avisos. El primero es